Welcome everyone to another edition of Drunk Agile. But before we get into whiskeys and introductions, I probably should start this episode off by saying we probably just did what, an hour Drunk
Yeah,
Agile episode
yeah.
and didn't record it, and like now we're finally like, you know what, we should have probably hit record. So
Which which is fair because I think the last couple of episodes were sober agile, so
yeah.
we're kind of already a little drunk.
So so with me as always is Pratik. Pratik, what are you drinking? What got us
Oh,
here?
it's stagnite.
Oh, okay, yeah,
It's stagnite. Yeah,
perfect, yeah.
65%.
65.1, yeah. Gotta be careful with
65.1.
that. Yeah.
Don't forget the point one.
I'm makes all the difference. We'll get to that. We'll get the don't forget the point one. Yeah, I'm excited because I just picked up this Glengarry when I was just in London. And this is my first time trying it. So it's a 13-year-old Glengarry bourbon cask, 55%. Not bad. Not great, but not bad. Um, so we were just talking, every other episode we do has to be because math, and without getting into the nitty-gritty details, I was sharing with Pratik a paper that I came across, was given to me against my will, I should say, about how a certain company was using Markov chain to model forecasts for single items, for individual items. Take it away, Pratik. I'm just stop right there and I'm gonna let you go.
Let's go. Let's go. All
All
right.
right.
So before we go a lot further, Markov chains. We don't have time to go into
Yeah.
explaining Markov chains,
Yeah.
but just so you need to have states and transitions between those states, and you assign probability to those transitions, and that's what forms a Markov chain. And you can use that for multiple different purposes, multiple reasons. One of which could be forecasting. You could potentially figure out run things through the Markov chain multiple times and do a Markov chain Monte Carlo. Okay, states and transitions. That is where there is a commonality to a Kanban board. Kanban board, each column is a state, and there are transitions between those columns. So you could potentially say things like from column A to column B, there is a 20% probability that a particular card on a given day
On a given
will
day.
move from column A to column B. Similarly, B to C, C to D. So you could see how you can run Monte Carlo simulations which take those transitions into account and figure out how long it takes for things to get done or how long it will take for things to get done. Um, that would be a Markov chain Monte Carlo for a single item, and you could probably figure out how many, if you run that over and over again, how many things get done in 8 days or less, 10 days or less, so on and so forth. Um, I don't necessarily think it's invalid, but at the same time, I do think it's unnecessary.
It's overkill. It's yeah.
The example that we were going with earlier, I'm sure we can come up with 20 other examples, is let's say this is equivalent to, let's say, and this probably applies to every because math episode. This is equivalent to say you want to pick a number between 1 and 6. Just you need to do this once, and hey, there's a six-sided die. Let's just roll that. We get a number between 1 and 6. That's an approach. You could do that, which is essentially the approach that we usually talk about. Look at a scatter plot and figure out. Or you could get a piece of uranium and know the decay rate of it, like observe the decay rate of it over time, and then go, which percentile does that decay rate fall into? And go, oh, this falls in the 40th percentile, so I should probably be picking 3 as that random number because it's in the third 41%, whatever. Let's say 41% to make it easier. But yeah, this should be there. So why would you go through all these shenanigans? And the only answer we have for that is because math.
Because my there because particularly left out some important points because you can't really just look at the decay rate of uranium, right? I mean, as I was telling Pratik, I mean, you need to control for certain factors, like if you're Catholic, is it a rainy Thursday in Lent?
True.
You forgot adding that one in, you know.
I forgot.
Just like
Does
this.
the decay rate decay rate match a Weibull distribution?
Well, see, you went just where I was going to go because that in this paper, it's not even as easy as we said, because what they're doing is they're taking real cycle time data and they're feeding it to a Weeble or however the hell you say that. Just we really probably should learn how to properly say that distribution name because I'm sure it's not Weeble, right? But let's just say Weeble because it's something like we bullshit anyway. Um, but they take cycle time data and they feed it to a Weeble distribution, and then they're basing those transition probabilities based on a Weeble distribution of fit data, not your data itself. It's your corrupted, perverted, whatever transposed data to come up with those Markov chain. And it's like that's that's where Pratik's uranium comes in. Maybe that's the blog post. Pratik's uranium.
It's like Schrodinger's cat. Schrodinger has cat. I have uranium.
It's so, I mean, but this is and yes, of course, we're being fairly facetious, but in all seriousness, I know a lot of us, probably a lot of you who are listening to this episode, and I hope all of you agree with, or most of you at least agree with this, is that yeah, you probably have a math background and you probably have a pretty serious math background, but one of the most important things about anything in math or maths, depending on where you're listening, is this notion of you have to understand the assumptions behind the tool you're using to understand whether it's valid or not, whether it's whether it's something that we can do. There's a reason why discrete cycle time data cannot be fed to a continuous Weeble distribution, right? That's just one thing right there. There's all kinds of other reasons why why that's not the case, but just stupid stuff like that, or your favorite of doing arithmetic uh,
on ordinal
on ordinal
values.
numbers. Yeah.
Yeah.
This kind of stuff. Just because you can do math doesn't mean you should.
Does
This is where the because math thing comes in. Sorry, what were you going to say,
yeah.
Pratik?
No, I was gonna say, we've been we on this podcast we have been talking about dependencies of late, and I think this fits in very nicely because whenever there are dependencies and transitions from one dependencies over into next, you could be lured into thinking that this kind of an approach would work well, and there are simpler approaches which hopefully in the next few episodes we're going to get into. Last time we posed the question of how would you answer if we had three teams dependent on each other, um, and this is frankly this is a way to answer that question. In fact, I think I remember someone in the comments did not say Markov chain but kind of alluded to, hey, can we find out what is the rate at which they miss or hit? But this is a way, um, but just because something is a way, just because you can use uranium to select a number between 1 and 6, it doesn't mean you should. The Occam's razor, whatever is the simplest solution, let's go towards that.
Yeah. So I don't know. I don't have much more to say because I think we've made the point. You know, just because somebody hands you a
What?
mathematical tool, what? Go ahead. Well,
Well,
okay.
I challenge,
Oh
challenge,
shit. I should have
challenge
hit
to the
stop.
listeners. Challenge to the listeners. What are some other creative ways you can come up with of selecting a number
Hmm.
between 1 and 6?
What's the
You know,
weirdest way? Yeah.
there is between the rainbow, the spectrum of using a dice versus using uranium. What are some other ways? Let's find out.
We, we, we want to hear from you. And wait, what was it? What was the Hasselhoff that
Oh, the Hasselhoff recursion.
is that what it was? Hasselhoff
That
recursion?
was the
Yeah.
Hasselhoff recursion
Yeah.
from Carl Scotland. Yes.
Yeah. Yeah. I think we talked about that. If I'm pretty sure we talked about that in a previous episode, either with Carl or not. So
Yeah.
your challenge is for all of you to go and watch all our previous Drunk Agile episodes and look up Hasselhoff recursion because it's kind of along the same lines, kind of.
You're gonna make people Google that.
I am. You get to give them homework.
This
I get
is
to give them
it. This
homework.
is it. We're losing subscribers.
Yeah. Well, if you're still listening right now, God bless you. Thank you. We just can't say thank you enough. God knows if this episode will ever see the light of day. But anyway, I think we'll cut it off there. Um, we're making up. I think we're making up for lost ground. Was the
Yeah,
last two or
yeah.
three that we were just
That's
drinking
two. That's
water?
two were
Or-
sober. So yeah,
Yeah. All
yeah.
right. So anyway, thanks all of you who've stuck with us. For Pratik Singh, my name is Daniel Vacanti. Appreciate you watching, and we will see you in the next episode. Good night, everyone.
Folks.
If you like this content, all of you know how YouTube works. Please like and subscribe to this channel. We'd love to get your feedback and love to put more quality content out for you. Pratik, what else can they do?
Use the links in the description to reach out to us. You can find us on LinkedIn. See if there's a way we can work together. That'd be awesome.
Yeah, we'd love to see you. Thanks everybody for watching, and we hope to see you again very, very soon.